We have booster ignition and liftoff of Columbia, reaching new heights for women in X-ray astronomy.
The main thing Chandra does is take these superb, sharp images.
Names in astronomy don't always tell the whole story. Let's take, for example, radio galaxies. Why, might you ask, would a Chandra podcast talk about such an object? The answer is that radio galaxies are, yes, very bright in radio emission, but they are also powerful emitters of X-rays, optical light, and from other parts of the electromagnetic spectrum. More than that, they are important objects that really have played a very big role in how the universe has evolved. Let's listen to Dr. Dan Evans from the Harvard-Smithsonian Center for Astrophysics as he explains why he thinks radio galaxies are so important to study.
Radio galaxies are the 10% of active galaxies that emit very bright radio emission. Radio emission comes out in the form of a collimated relativistic jet. Now, radio galaxies are really important for the universe as a whole because they act as energy-carrying channels. They transport energy from the black hole radius on which they're created out to really, really big distances perhaps in excess of 300 to 400 million light years. So you can see that radio galaxies actually have a cosmological importance. By transporting the energy out to these vast distances, they affect their environments and they affect the universe as a whole.
So what does an X-ray telescope like Chandra have to do with these objects that are so well known for their giant output of radio waves?
Chandra observations really form the cornerstone of research into radio galaxies. And this is because black holes and their accretion processes are really strong sources of X-ray emission. Not only that, in active galaxies with radio jets, we can see acceleration of particles in magnetic fields up to X-ray energies. And finally, those jets propagate through gaseous environments. Now in the case of radio galaxies, the gas is incredibly hot, of 1 million degrees or so, and that's X-ray hot. So by studying the core, the jet, and the hot gas environment in which radio galaxies are embedded, we can really begin to piece together the pieces of evidence associated with black hole activity in AGN.
Recently, Dan Evans and his colleagues made a discovery about a particularly special radio galaxy. This system, known as 3C321, contains something that astronomers had never seen before. Dan Evans explains why they were so excited about this system, which is about 1.4 billion light-years from Earth.
3C321 is a particularly unique case. In this source only, we see the jet that comes out of one galaxy that's associated with a black hole and actually smacks into the side of a second galaxy. Now onwards, that jet diffuses and it becomes disrupted. If you were sitting on a planet in that other galaxy, you would expect to see an enormous amount of radiation, and the jet itself would cause really damaging effects to the planetary atmospheres in that galaxy.
3C321 is a great example of how one telescope cannot tell the whole story of our universe. So while it's classified as a radio galaxy because of the conventions used by astronomers from decades ago, it's obvious that many viewpoints are needed to get to the heart of the matter. Dan Evans talks about combining individual elements so the sum is truly greater than its parts.
By tying together observations with NASA's fleet of great observatories, those are the Chandra, the Spitzer, and the Hubble Space Telescopes, together with ground-based information from the very large array of radio antennae in New Mexico, we can really begin to understand the physical processes present. For example, the radio traces emission from the jet, the X-ray emission traces the activity associated with the black hole, and then the optical and infrared data show us really how the two galaxies are in the process of merging. So it's only by combining these four pieces of information that we can really begin to establish the complete picture of the 3C321 system.
Remember, don't let names in astronomy fool you. They were often given before scientists truly knew what they were looking at. In today's astronomy, it's important to study radio galaxies in many types of radiation. Only then can the real picture of the universe, in all of its complexity, truly emerge. For more information, visit our website at chandra.harvard.edu.
This was a production of the Chandra X-ray Center, Cambridge, Massachusetts. NASA's Marshall Space Flight Center manages the Chandra program. The Smithsonian Astrophysical Observatory controls science and flight operations from the Chandra X-ray Center.